Welcome to MATLAB Helpers live coding contest, live coding webinar on Arduino with MATLAB. So in this webinar, we are going to cover a lot of basic applications using Arduino. As you might have already seen in the description box, we'll be covering how to download and install the hardware packages. We'll be covering the basic Blink program, how to blink the onboard LED on Arduino, and we'll be also covering how to blink the external LED. So we already have made a kit on, like, if you want to use it using Arduino, we have already made the kit and you can buy it from our website, which is mlhb.link/Arduino kit. You can find the link in the description below. And a lot of people had actually bought this kit, and they would be working along with me today. So if you guys already have the Arduino kit, or at least you have one Arduino like the Uno or Mega, you can work along with me. And this being the live coding webinar, you can ask your questions in the comment sections, either in the YouTube page down below, or you can start a chat on our website, which is matlabhelper.com. You can start a chat over there and chat with our executives to uh, know or to get your query solved. So along with the Blink thing, we are also gonna see how we'll be integrating servo motor with Arduino. And last but not the least, we'll be also seeing how to exactly program Arduino using Simulink. So without writing one line of code, we'll be doing that with MATLAB. So let's start with it. Okay, so let me share my screen and okay. So I've already written a quote on hello all, welcome to live coding webinar organized by MATLAB Helper in association with Eravat Foundation. So Eravat Foundation is an NGO whose tagline is "We do the impossible," and their mission is to support a human progress through innovation and technological advancement. So these guys are working on a very cool technologies, and you can also support them and also join them by visiting their website, which is eravat.ngo. Again, you can find all the links which I'll be mentioning in the entire webinar in the description box below. And if you could not find it, do comment it in the comment section. You can comment it on our website. You can start an online chat on our website, and feel free to ask as many questions as you can. So let's start with the first very topic. So this is the MATLAB interface, and we'll be working totally with MATLAB in the first stage, and then we'll be going to the Simulink portion. So to install the hardware support packages, what we will be doing is just navigate to your home tab in your MATLAB. You'll find add-ons button over here. So you can just click on the drop-down option over here. You can find the Get Hardware Support Packages option over here. So I'm just clicking on Get Hardware Support Packages. And here you can see the MATLAB support package. It might not appear first in your case, but I've already installed the Simulink support package for Arduino to save a bit of time. I'll be showing you how to exactly install these MATLAB support packages on your device as well. So just have to click on these MATLAB support packages. Here you'll find an option to install it. So once you click on install, there are two options again, install and download only. So we'll be going with the installation steps in order to check if the Arduino is working or not. So let's click on install over here. This would take some 2 or 3 minutes. And you need to sign in using your MathWorks account Again, you can create your MathWorks account on their website, which is again free of cost. You can use this toolbox and with no additional costs. So you can sign up free. You can get your account with MathWorks and install any toolbox which is available for free. So once you have already, like I have already signed in. So once you're done with the sign in part, you can just read the software license agreement and click on I accept. So I'm just clicking next, and it will take some, it will take some couple of minutes. To download the support packages and the third-party packages as well. So meanwhile, this is getting downloaded. Okay, so you just have to click yes every time is asked for the permission. So if it asks for setup.exe permission, you have to click yes. Yeah, so meanwhile, this is getting installed and configured. How many of you have already bought the Arduino kits from our website or from anywhere else, and you have worked on Arduino from the Arduino IDE itself? I'm not asking about MATLAB. So if you have worked on Arduino and you know some basics of it, just let me know through the comment section below so that even I can understand from where to, like, how to start with the webinar. So we can just go from the scratch itself. So here you can see the installation is complete and it asks for two options, setup now or setup later. So we are going to set up along with this, and let me click on setup now. So you can see Arduino USB driver installation, but before that, you also have to connect your Arduino to your computer. So to do that, let me show you the Arduino connections first. So as you can see over here, we are using Arduino Uno for all our purposes. Like I'll be using it in all the further applications as well. So I'm going to connect this Arduino with the computer using the USB type B. This wire usually comes with the Arduino, and if you have already bought the kit from our website, you will be provided with such Arduino kit wires. So you just have to connect your Arduino board to your computer, and that's it. Once you're done with it, let us come back to the MATLAB terminal. So it asks for Arduino USB drivers. So I'll just click on, I'll enable the installation of Arduino USB driver and click on next. I'll click on yes for all the permissions asked again. So it's been set up now, and it asks for, do you want to set up your Arduino board connection? So I'll just click on yes, because we will be doing it along with, before starting with any of the codes. So I've not disconnected the Arduino hardware, as you can see in the small video over here. So I'm just clicking on next button here. Now there are three options: USB, Bluetooth, and Wi-Fi. So I'll be connecting it through USB. So I've selected the radio button as USB. Let's click on next. Now there's an option to choose the board. Since I've already told you we'll be using the Arduino Uno, so I'll be selecting the Arduino Uno board from the drop-down. I'll be checking all the libraries, we'll be installing all the libraries at the beginning, but it depends upon you. If you want to install few selected libraries, you can do so. Next is we have to also choose the port. So this port is connected on COM4, and if you cannot see the COM4 over here, so make sure you have the Arduino drivers installed on your computer. So to do that, either install this support package again, or just get the drivers from the internet, from the Arduino website itself. So it should appear some another COM. So it's not necessary that it should be COM4, but it can be COM3, it can be COM2, it can be COM4 as per your computer. So it's COM4 over here. I'll be selecting that and I'll click on the button program over here. So once I click on it, it will update the server code on Arduino Uno board, which is connected at COM4. So meanwhile, it's uploading the code to the server. Okay, so it says that success, the program is already uploaded. So before moving ahead, let me tell you a few more things about Arduino Uno. Let me bring it to the full screen. So this being the Arduino Uno board, we have these two LEDs, which is the power button and the pin number 13 LED, which is the onboard LED. It's called the onboard LED. This is the power button or the power indicator. Then we have a few lines over here, where pin lines over here, which starts from pin number 13. Actually, we have a ground before that. Then we have a pin number 13. We have pin number 12, 10, 9, 8, 7, 6. So basically, we have 13 digital pins over here. We have power supply grid over here, which gives 3.35 volt. We have two grounds. We have one VCC. So depending upon the application, you can use the power grid over here. Next is we have the analog pins over here. So in analog pins, we have 5 analog pins, which are named as A0, A1, A2, A3, A4, and A5. So on Arduino Uno specifically, we have 13 digital pins and 5 analog pins. And if you go to the higher versions of Arduino, say Arduino Mega or Arduino Duo, so in that you will find more number of analog pins or more number of digital pins. So make sure that you always find the data sheet for every Arduino, or at least if you cannot read the data sheet, make sure that you Google out, because on my personal experience, I'll tell you one thing. Similar to Arduino Uno, we also have an Arduino called Arduino Duo, and I was using that without reading the data sheet. And what happened was the Arduino Duo serial communication occurs on 3.3 volts, which is 5 volts in all the other Arduinos, and I was unaware of it, and I used it with 5 volts, and the Arduino was corrupted. So make sure that you read the data sheets every time before using any of these hardwares. At least Google it so that you know some basics of it, like which exactly are the digital pins, which are the analog pins, and why exactly do we use the power grids or the power pins over here. So now let's move ahead with the coding part. Yeah, so in the setup portion, I'll click on next over here. Now we can actually test the connection by, clicking on this button over here, test. It will, again, you can see on the Arduino, it will bring the pin number 13 LT, and it says the test is successful. And to test further, you can type A equals to Arduino if you want to check if everything is good or not. So I'll just click on next. If you can see the examples for support packages. So I'm just unchecking this for now. I'll click on finish. And we are done with the installation of support packages. So anytime if you want to set up a new Arduino, you can navigate to manage add-ons, and in the manage tab you can just go to the settings over here. You can go to the setup if you want to set up any new Arduino, or you want to do it again. So you can just click on setup and go ahead. So this is how you have to install the support packages on MATLAB before actually coding it on the Arduino. So if you guys have any queries, if you have any doubt, let us know through the comment section below. We'll be taking it at the end of the seminar, or I'll be just taking it along with it. So if you have any queries, let me know so that we can move ahead. You can either comment in the YouTube comment section. You can also comment on our website. You can start an online chat at our website, but make sure that you ask as many doubts as you can. And all the candidates who have already brought these Arduino kits from us, make sure that you connect them well, and if you have any queries, you can again comment in the section below. So let's start with the first actual coding part, like we have done with the installation, and let's start with the Blink program now. Let me create a new script. So basically, okay, before that, let us test the connection of Arduino, if the Arduino is successfully connected or not. We have done that using GUI, but it's not that every time we are going to use the setup of the Arduino. So if you have connected a new Arduino and still want to check if the connection is proper or not, so just in the command prompt you need to type A equals to Arduino, and that's it. That should work. Oops, I just ended it with the semicolon, which did not give me any results. So you can see it gives me an error called MATLAB connection to Arduino Uno at COM4 exists in your workspace. So this is a very important point. Whenever you start with the code, make sure that you write clear all. Like you need a clear workspace. Only one connection can be set up to one hardware at a time in MATLAB. So you need to clear the workspace variables. I'll also clear the command window and then again test if Arduino works or not. Yeah, you can see it's connected at port COM4 at port Uno. And as I said, there are 13 digital pins and 5 analog pins as well. So now let's start with the coding. And in the first part, like in the first code, we are going to go for the blink code. We're going to blink the onboard LED, which is pin number 13. So to do that, let's clear all and CLC. So these lines, as I said, are very important to clear the workspaces. So let us start a connection. A equals to Arduino. And to actually write any digital output to Arduino, we use the command write digital pin. So this is the command for giving the output. So you can see the MATLAB helps us in adding the attributes to this function, write digital pin. So A's are Arduino pin number. So we are going to use the onboard LED, which is pin number 13. So we have to type pin number 13, but make sure that this being a digital pin, you have to add a prefix to it, which is D13. And if it's an analog pin, you have to add it as A0 or A1, since we just have 5 analog pins on Arduino Uno. So once we are done with that, we need to put the value. It's either high or it's either low. So for high, we denote it as 1. For low, we denote it as 0. So for high, I'm just putting it as 1. And then I'll be adding a pause. Say if I want to add a pause of 0.5 seconds. So I'm adding a pause of 5.5 seconds in MATLAB and in Arduino. This is a difference while coding. So pause 0.5 in MATLAB, like this value is considered in seconds. So these are 0.5 seconds. And in Arduino, whenever you put the time or you put the delay, so that is always considered in milliseconds. So make sure that you don't get confused in both the languages. And we have also made a quiz on Arduino, which you can find on our live MATLAB page. Like you can just go to mlhp.link/live. And if you're watching this video from our website itself, you can just navigate below to find that quiz, and you can answer those questions, and surely you can get some gift hampers from us. So moving ahead, we have already added the pause, and now let us turn off the LED. So it's like write digital pin A equals to Arduino. Again, the pin number is 13, and now we are going to set the value as 0. So we have a comment from Shobhan Chatterjee, and he's asking, do we need to log into our MathWorks account before the installation of hardware support packages? Can it not be done without an account? No, Shobhan, you cannot do it without actually creating the MathWorks account. So you will have to first create the MathWorks account, which is, as I said, it's free. You do not have to pay for any of for creating the account. And again, the Arduino toolbox, like the support package, is for free. So you just have to create an account on MathWorks, and then you can use all the free tools of MathWorks with your MATLAB. So that's a compulsion on using the MathWorks account. I hope that solves your query. And that's actually a nice query, so that others can also know about this thing. And those who are joining late can actually scroll from the starting, or start this video from the starting, like from the left of the scroll button below, so that you do not miss any of the portion. And if you want to still go live with me, you can watch live with me. So now we are working on the Blink code. We have already set up the connection. So this line of code is used for setting up the connection. We have passed the variable, like we have given high to pin number 13. Then we have added a pause of 0.5 seconds. We have added low to pin number 13 again. And then again, we'll add a pause of 0.5 seconds. So what basically will happen is the LED will glow for 0.5 seconds, and it will turn off for 5 seconds. So let us quickly push this code to Arduino. We just have to click on run button over here. You'll have to save this. I'll just replace the file. So, okay. I'll show you the Arduino part of it. So I'm running the code again, and as you can see, it will just run for once. What we need to do still is we need to put some value, or design the code in such a way that the LEDs will keep on glowing, on and off. So that state should be changed eventually. So let's add a for loop over here for I equals to 1 is to 10. So I'm just adding, say, 10 loops, and then I'm just ending the for loop. So what will happen is this will happen for, or the on and off cycle will happen for 10 times, and later on the code will stop. So before that, let me also tell you the indentation part. Like, these are the basic code ethics which I'm using. You need to comment each and every line. You need to specify what exactly we are doing. So this is something which is not compulsory while coding in any of the languages, but it's a good habit, or it's a good code ethics to write the comments. And then there's again one thing, which is the indentation. So we have a very good tool in MATLAB which is called the Smart Indent over here. So once we click on this, you'll find everything in the code gets indented properly. So once we are done with the indentation, let me show you the output of this code. So you can see the LED is being on for 5 seconds. Sorry, 0.5 seconds. It's been off for 0.5 seconds. So the code has stopped running now. So you can experiment these things. Like, there are a lot of values which you can change. So we have yet another query on our website which says, like, how can we differentiate between various Arduino types, and can I use Raspberry Pi as well, just like I am using the Arduino? Yes, actually, you can use Raspberry Pi to program any of your projects. But the basic difference between Arduino and Raspberry Pi, you need to understand, this being a microcontroller and that being a microprocessor, it has a different approach in programming. But yes, it's the process is very much similar. Like, this being an Arduino Uno board, just like I have installed the support packages for Arduino, you also have the support packages for Raspberry Pi or the other hardware packages. So just let me show you that. And I'm also answering the other question, which is how can we differentiate between various types of Arduino? So basically, it depends upon the usage of Arduino. Say, for example, it's a hobby project, or you want to experiment with very few parameters, or say 2 or 3 sensors. So we'll be using Arduino Uno, but to just give you an update, there's also Arduino Mini, which is much more smaller than this Arduino Uno. So that can be again used for hobby purposes. The basic difference is this Atmel chip, which is used in all these Arduino. So the processing speeds, the input-output serial communication, the number of digital pins, the number of analog pins. As I said, the power source, like in Dio, it's 3.3. Everything works on 3.3. In other Arduino, it works on 5 volts. So that's the basic difference. Like, it depends upon the application which you want to use, and depending upon that, you can buy the Arduino, say Arduino Uno or Arduino Mega, as per your need. Since I was showing you the add-on explorer for Raspberry Pi, you can actually install the MATLAB support package for Raspberry Pi. And if you're working on Simulink, you need to install the Simulink support package for Raspberry Pi hardware. Okay, coming back to our Blink code. Now, I just want to keep on switching on the LED and switching off the LED for infinite number of times. So I'll be just writing in the for loop 1 to INF. INF in MATLAB means infinite, so it will keep on running. Okay, so let us quickly run it now. You can see there's a warning in MATLAB that there are too many for loop iterations and can just, take these many iterations, which is 9, 2, 2, 3, 3, that's a big number again. So I'm not going to count it. But yeah, you can keep it as infinity. And as you can see in on the Arduino, the onboard LED, which is pin number 13 LED, keeps on blinking for zero point 0.5 and keeps on turning it's an off state for 0.5 seconds. Now let us change this delay. But before that, you need to stop the code which is already running, and you cannot actually wait for these many number of iterations. And to do so in MATLAB, like in command window, if you want to stop any code, you just have to press Control and C. So you can see the operation is terminated by the user, and now we can change the code. Now I'm just taking this as infinity as 100, and I'm changing the pause value, like the delay value for which the LED would be on for, say 2 seconds, and I'm changing like it will be off for say 3 seconds. So it will be on for 2 seconds and it will be off for 3 seconds. You can change the value as per the application or as per your requirement. So it's a fun event or fun thing which you can actually do. You can experiment a lot of things with a simple blink code as well. So the code has been uploaded now. You can see the LED is being on for 2 seconds. Again, it's off for 3 seconds, then it's on for 2 seconds, and this will keep on happening for n number of times. Like I have put it as infinity and it will keep on happening. So coming to the code portion again. Now let's play around with the code to understand few more basic things about Arduino. So this is like we have completed the serial output, or how to actually send any data to the Arduino pin. So we have learned this using write digital pin. So we just have two commands. One is which I have discussed right now, and another one is which I'll be discussing in the later phase. Like I'll be discussing when we are doing other hardware like the servo motor and all. So we have done how to exactly send the data to Arduino. In the next portion, we'll be doing it how to read the data. But before that, let us make it more fun by asking the user to change the value of these delays, or asking the user to change the value, change the state of the LED. So let's go with the first one. I'm just asking the user input how many seconds should the LED glow. And then I'm changing the pause value of it to value, which is the variable I assigned over here. Again, before even changing, I should have stopped the code which is already running on Arduino. So to do that, I'll be pressing Control C, and you can see operation is terminated. And now I can actually run the code. So it says how many seconds should the LED glow. Say for example, I am saying that the LED should glow for 5 seconds. I hit enter, and on the Arduino board, you can see the LED will be on for 5 seconds and it will be off for 3 seconds. So coming back to our code, and before proceeding, let's stop because we are doing a lot of iterations over here. We are taking 100 iterations here. Now, how about asking the user the state of LED? How about doing that? So I'm just taking first few lines of code, which is the common lines of code in all our codes or all our applications today. So I'm just setting up the connection over here, and this time I'll be asking the state of the LED, like it should be on or it should be off. And that's what I'm going to ask in the command prompt itself. So this is the way you can communicate through like you can set up a serial communication from Arduino command window over here to the Arduino, like the pins, the actual pins over here. So I'm going to ask set the LED to, and I'll be giving two options. Number one is on and number two is off. Now your \n is a command which is used, to take the string to the next line, and which is used in input. It can be used in fprint. It can be used in sprint, but it cannot be used in display function of MATLAB. So just to tell you about that. And this time we'll be using a switch case, switch state, case number one. So what's our case number one, which is the LED should be on. So I'm going to write digital pin to Arduino pin number 13, safety 13. And I'm going to put it as high, and I'll give you a pause of say 2 seconds. And case 2 is write digital pin with the off instructions. So I'm pretty sure you are much familiar with these on and off instructions now. And if you still have any queries, if you still have any doubt, you can comment down in the section below. I'm repeating these things again so that all your doubts are getting cleared. And okay, so I'm just ending the switch case. Now let me run the code for you. Let us save it as blank external. Now you can see in the command window, it will ask whether to set the LED on or to set the LED off. So I'll set the LED off because in the first stage, like in the small window over here, you can see the LED is on over here. So I'll change it to off, and you can see that's turned off. But now there's an issue. This code keeps on running just for one iteration. Let's do it for, increase the number of iterations. Like it should keep on asking the user to turn on or turn off the LED. So this time we'll be using a while loop instead of a for loop. So let's use while time is less than 100. Say for example, I'm just setting time as 100. And for time which is less than 100, if it's less than 100, the loop will keep on running. But before that, you like in for loop, the iteration keeps on happening. Like the number keeps on increasing from 1 to 10 automatically, whereas in while loop, you'll have to decrease it manually. So I'm just adding one more line, which is time equals to time minus 1. And end the while loop. One more thing I need to do is I will be shifting this part inside the while loop, because at each and every stage, we need to ask this question to the user. So I'm just clicking everything using the smart indentation feature of MATLAB, and I'll run the code. Okay, there's some error over here. You can see the time is been set to 100 and says like, if the time is less than 100, we have to do this. So what do you suggest? What's the change over here? what should be the number of time over here? Can you suggest some logic? Come on, I'm just waiting for your answer. You can comment down in the section below, and if you haven't understood, tell me so that I can repeat all those things again. Changes, we just have to click on greater than, and this should be 0. So if time is greater than 0, the loop will run, otherwise it won't. So let us run the loop again, and this time it should work. Yeah, so it's asking for what should be the state of LED, and as you can see, it's on, so I'm just turning it off. Again, it will ask what's the state of LED. So I'm pushing it as 1. And then again off, on, off. So I can do it n number of times. I can just play around with it for the entire day. And to stop the code, again, as I said, I'll have to hit Control C. You guys cannot see the screen. I can just increase the size. And once you click on Control C, the operation would be terminated. So let me clear the screen, clear the command window. Now, this is how we are going to control the Arduino, control the LED, which is the onboard LED using Arduino. Now, let us quickly do this using an external LED. So I'm not just changing the code, like I'm not going to change the code, but we'll be adding few more things to the hardware. So I'll just stop my screen. And so coming back to our Arduino, those who have bought the Arduino kit online would have got some similar breadboard. So I'm just taking that breadboard with me. I'll be taking one LED which I have of a 3.3 volt LED, and you can see there are two terminals of the LED. Which is the longer leg is always positive, and the shorter leg is always negative. So make sure you connect positive to positive and negative to negative. Otherwise, the LED will just blow off. I'm just connecting the LED on the breadboard in parallel, not in series. In breadboard, these connections are in series. These connections are in series, and all these connections are in parallel. So I'm just connecting it on breadboard. I'll be requiring 2 jumper wires. So one of which I'll be adding to pin number 13. And the pin number 13 wire will be, going to the positive terminal of the Arduino. The positive terminal of the LED. So I'm just checking it once again. So I'm just putting it to the positive terminal of the LED, and the negative terminal would go to the ground. So you can find ground terminal which is besides pin number 13 itself, or you can also use the power grid over here, which is this portion. You can use any of the pins from here. Fine. So let us go to our MATLAB window, and I'll be running the code for once again. So I guess you can see the LED better now, and I'm just turning on the LED. So that's on. You guys can see that in the small window over here. And if you want to see it in the larger window, just tell me. I'll be doing this for 2-3 more times, like 2-3 more iterations. Just turning it off and turning it on. And let me show you in a full screen mode. I'm turning it on, turning it off, on again, off again. So this is a basic code through which you can turn any appliance, or not just an LED. You can turn it on, you can turn it off by just writing or by just giving a digital high to that pin. Okay, so coming back to our lab screen. Now next we are going to control a servo motor using same Arduino Uno. And the principle of servo motor is very much similar, but just let me take you to a new script. Let me, clear the command window and let's start from the beginning. Now in this part, we are going to control a servo motor using MATLAB. So let us set up a connection, but before that, very important thing, every time we need to write as clear all CLZ so that all the attributes from the workspace are clear. And then A equals to Arduino. Okay, one more thing I want to mention over here. If your Arduino board is not detected, okay, if your Arduino board does not get detected with just A equals to Arduino, when you type A equals to Arduino, it shows some error that the COM port does not match. So in that case, you can actually write it manually, like, give the attributes manually. So the first attribute would be Arduino in the bracket, the COM port on which it is connected. So you can write Arduino COM4. And next is the board which you want to connect. So it's like comma. So we are connected to a board Uno, and this should okay. So again, you should clear the variable before setting up a new connection. So I'm doing it again, and this should work. So you can see port it's connected at COM port 4 with port Uno. It gives the same instructions as we got in the single line. So even if you don't write it, or if you write Arduino in this way, if you write the entire thing, that doesn't actually make any change. Now, let's bring the servo motor into the picture and let me explain you the terminals of servo motor. So we have 3 wires which will be coming out of the servo motor, which is brown, red, and yellow. So the red wire is always for the positive connection, like the +5 voltage connection. The brown wire or the black wire is the ground wire, and the yellow wire over here is for sending the data. It's called the control pin, which will be connecting to the pin number 4 of Arduino. So let us connect it. I'm just removing the LED as of now. For extra security, you can just turn off the Arduino and plug it out so that there's no damage to the Arduino. Yeah, so I've just plugged the Arduino out so that you guys can also see it clearly. Now I'm just connecting these terminals of the servo motor with the jumper wires. So I'm connecting the yellow pin with the pin number 4, like the digital pin number 4 of Arduino. So you can just 0, 1, 2, 3, and 4. So I'm just connecting it to pin number 4 of Arduino. And see, I've connected it to pin number 4 of Arduino over here. I know, guys, if it's not clear, you can ask all your questions in the comment section below, and even afterwards, if you don't have the kit right now, and if you are just watching the webinar, and if you want to do it later on, you can just comment on the same video, or you can comment on our blog, which is on our website. You can find the same information there, and you can get all your queries resolved. So I've connected the the yellow wire to pin number 4 of Arduino. Now let's connect the remaining wires, which is the red wire. So red wire is something which I'm going to connect to to VCC. But now I'm not connecting it to pin I'm not connecting it to VCC because I'm going to show you one more thing. So I'm connecting it to pin number 13 as of now. Okay, so we'll be controlling the power of the servo motor as well. Now next is the ground wire. So just plug the ground wire or to the servo motor and put it anywhere on the board, like to the ground pin. You can see over here, there's a ground pin besides the pin number 13. There are two ground pins in the power grid as well. So over here. So yeah, we are done with the connections now. I'm just cleaning my table so that you can clearly see the servo motor. So this is the Arduino and that's the servo. Let me connect the Arduino to the power. And 1 second, let's go to the MATLAB screen. Okay, I'm just setting it in such a way that you can see the servo motor clearly, because it's very important to see the rotation or the direction to which the servo motor is going to point. So what I can do is let me share my screen and let's go ahead with the settings of servo motor. So for servo, like to initialize servo, we have another function in MATLAB, which is s equals to servo, and which is connected at pin number A. I'm sorry, it's connected at pin number A and digital 4. So the servo is connected at pin number 4, like the control is connected at pin number 4. Now we are going to use a for loop, which will keep on checking what's the angle of the servo. But before that, let me tell you the servo motor which I am using is a MG90S motor, which is a 180 degree rotational motor. Okay, it rotates for only 180 degrees. And while calculating the step angles, it's very important to know if the motor is 180 or 360. So the motor which I am using is 180 degree. And if you have bought it from our website, again, you'll be using the same model of the motor, and it's a 180 degree motor. Okay. So I'm just putting it down for now. So I'm going to set the angle as 0 to 1. Again, it should, if it's at 0, it's at the initial position, which is at 0 degrees. And if it's at 1, it's at the maximum position, which is at 180 degrees. And in case of a 360 degree motor, it's at 360 degrees. But in between, we need to stop the motor. And to do that, say for example, we have a total of 180 degrees and we need to divide 180 in steps of 5. Let us do the calculation using command window itself. So we have 180 degree motor and we want to stop it at 5 different positions. So just dividing 180 by 5, which gives me an answer of 36. So we can stop the motor at 36 degrees intervals. So to set that interval, like you have to divide the 0 to 1 into 5 steps as well. So if you divide 1 by 5, if you divide 1 by 5, like we are doing 5 steps, it gives you a value of 0.2, and that's the value which we are going to use as the intermediate value over here. So the value actually will go from 0, 0.2, 0.4, 0.6, 0.8, and finally 1. So that would be the 5 steps in the servo motor. Now to write the position, we use the direct function write position s comma angle. Okay, that's pretty easy to write the position to any servo, but see to it that the current position of the motor matters. So you cannot just tell if the motor is at the initial stage. You cannot you can always say that rotate 180 degrees, but if it's at 180, you cannot say it that go further 180, because that's the limitation of the motor. And to do that, like to set those values, we'll be assigning one more variable, which is the current position of the motor. So current position of the motor equals to, you will have to read the position of the current motor. So to write the position, we use the command write position, and to read it, we use the command read position. So read position of servo motor S. Once you are done with that, we'll be changing the current position of this motor to, say, current position, whatever the position is, into our angle. Okay, which is 180 degrees. See, for example, if the position is 0.1, like the motor would give the values from 0 to 1 itself, and the position is at 0.1, you have to multiply it by 180 in case of a 180 degree motor. And we are also going to add a few more things, which is fprint. It will tell us the current motor position. Motor position is percentage D. Now I want to fetch the value from a variable into a string. So I will be using this percentage D, and I'm writing degrees. Now we also had one more question from our website chat, which is, why do we use this \n? So basically we are using this \n so that in the command window, the string which is ahead of it goes to the next line directly. Now to demonstrate that, let me show you. I'm writing fprint, say the name as MATLAB, and if it's an entire string, say MATLAB helper. So you can see I just wrote fprint. It should be fprint f. Let me just clear the window and write it again, fprint f. And I'm just writing the string as MATLAB helper. So you can see the string is being printed in one single line. Now, if I want to separate it into two lines, I'll just add \n, and MATLAB and helper would be separated. Now, in this case, again, we want to add the new command to the next line, and that's why we are using it at the end of this statement. But don't forget to mention the variable which is to be put here. So that's the percentage D sign. We need to assign the variable which is current position. And we will add another pause of 2 seconds just to change the value of the motor. And we are done with the for loop. So let us run the code and check if the servo motor is running or not. So I'm just running the code. Let me first show you. Okay, we need to save the code as well. So I'm just replacing it. Okay, again, there's an error because I did not add F over here, and then I'll run the code again. Yeah. So now you can see the current position of the motor is 0 degrees, moves to 36, 72, 108, 144, but that is happening only in command prompt, and that's not happening on the servo motor. Can anyone tell me the reason for it? I already have shared the hint before we actually started started coding this part. Can you guys tell me what can be the probable setting which we might have missed? we haven't given any power to this motor yet. I have told you in the starting that we'll be connecting it to pin number 13 instead of pin number 5. So we need to add an additional line before the for loop, which is write digital pin of Arduino at pin number 13, and the value should be high. So just writing it, and now we'll run the code. So current position of the motor is 0, current position of motor is 36, 72, 108, and 144, 180. So it's working. No, it's still not working. So that was the reason I wanted to show this thing to you, because even if you give 5 volts on a digital pin, that makes a difference. So you need to use the power grid, and again going back to our main circuit, I'll be changing the pin number 13 value with 5 volts. Let me run the code again. Now you can see, you might have heard the sound of the motor. So you can see the motor is rotating. Let me run the code again. Okay, so let me also show you the command window. So you can see the current motor position is 0 because we set it to 0. Then it was 36 degrees, then 72 degrees, 108 degrees, 144 degrees, and finally 180 degrees. So this is how you can program it as per your application. What you can do is you can actually ask the user to input what the position should be, and we can do it in the similar way which we did for an LED. So we had another question based on the power supply, as I was explaining the digital pin and everything. So we have another question: what is the power level going to Arduino? Is it coming from MATLAB or it's coming from your system? What will happen if there is less or higher power given to Arduino from MATLAB system? So basically, you can on Arduino. Let me show you. On Arduino, you'll find 2 ports over here. One is the type B port, which goes to your computer, through which I have connected. So this Arduino is being powered by my system. It's not by MATLAB, but my system which I'm using. So even if you do not have MATLAB on your system, and if you connect it to any of the USB, you can actually use this MATLAB. And there's another port over here, which is a circular port, and that's for a power adapter. So you can actually buy a 5-volt power adapter from any of your local hardware store and connect it over here so that the Arduino would work. But to program the Arduino, you have to specifically use this USB-B type. So that won't work from the power supply. I hope that solves your query. And as if you still have such similar queries, you can comment down in the YouTube section, or you can start the online chat from our website too. And that was the reason I actually demonstrated this code over here, which is write digital pin. And even if you give the digital pin a maximum value, it would not take it. So now we can, do some more fun with the servo part. We can, ask the input from the user. Say if I change this I equals to 0 to 100, So we're taking 100 equation. And now value of angle is something which the user is giving. What angle should be set to the server. Okay. Now make sure that the answer is between 0 to 1. So let me run the code. Now you have an option to okay, there's an error over here, not enough arguments. Okay, that's the reason, because there's an error in this line. We need to assign the variable and need to ask this from the user. So just forgot one function over here, which is input. I'll run the code and it should ask from the user what angle should be set to server. Now we in the starting had set 0, 0.2, 0.4, 0.6 and 0.8 and finally 1. But now you have an option to actually set the angle to, say for example, I'm setting it to 0.1. And see the server moved at 0.1. So current position is 18 degrees instead of the stereotypical like 0.2, 0.3, whatever the degrees were. So now say if I am taking it to 0.15, so that's 27 degrees. 0.26, furthermore, and then 0.5. 0.5 is 90 degrees. 0.6, 0.8. Let me show you the servo itself so that you can also do it along with me. So I'm again setting it to 0.1. So you can see it's been gone back to the position of 18 degrees. I'm setting it to the highest, 180 degrees at 1. It's gone at 180 degrees, 0.5 at 90 degrees. So this is how you can actually experiment with your servo, and depending upon the application, you can program the servo in this fashion. You need to stop the code before proceeding, for which you will be using the Control-C button. Now, for example, say if the servo motor is not detected at your pin. So in that case, what you will be doing is just enter this line in your command window without the colons, without the semicolons, and it says undefined function or variable A. So you need to also add this line before you need to set up a connection with Arduino first and then with the servo motor. So once you do that, and if you have connected a servo in a proper fashion, like at the pin number 4, so you can see pins D4, you can find the servo is connected to pin D4 with the minimum pulse duration of 5.44 to 10 raised to minus 0.04 seconds and maximum pulse duration from this. So this is the way you can actually check the servo motor if that's connected or not. So every time clear on and CLC is a really good habit. Now let me show you how to read the value from from a external sensor or from any of the external hardwares. In the first program, that's the Blink program, I told you how to write the values to the Arduino, and in this part we'll be telling you how to read the values. So I'll be using a potentiometer in this case, which is a 1K potentiometer. You can see over here, this is a 1K potentiometer, and I've already soldered it with 3 pins. The end terminals, like this terminal and the bottommost terminal, like there are 3 terminals, like terminal number 1 and terminal number 3 are the end terminals to which you will be connecting the voltages, and at the middle terminal you will be getting the regulated output. or the variable terminal is the middle terminal. So we'll be getting a regulated output at pin number 2. So let us connect this potentiometer on the breadboard. So again, I'm connecting this potentiometer on the breadboard in parallel, not in series, but in parallel. So I'm just putting it in the breadboard in the parallel situation. And I'm disconnecting the Arduino from my computer just by pulling this cable from here. You can also pull the USB cable from the from your system, so that there's no power issues, or even if you make the connections wrong, the Arduino would not get corrupted. And I'm removing the connections of servo motor. If you guys have any queries in servo motor problem, do let me know through the comment section below, so that I can reconnect it and I can show you. This being a live coding session, you guys are expected to work with me. And if you don't have the kit, don't worry, you can buy it from mlhp.link/Arduino kit. The link is given in the description box below. You can buy it at a very discounted rate from our website. You'll get all the kit, and you just have to assemble it. You just have to play around with it, and you can learn it. So it's not limited to this webinar. We will be using this kit in the future webinars as well. So we'll be having few more webinars in the coming months, depending upon the level of level of using this Arduino. Like this being a very first webinar, we are covering the scratch things. Like we are covering the very basics of coding, like the potentiometer, how to read write, the serial communication. But that is something which will not cover in the future applications, in our future live coding sessions. So you need to be you need to have hands-on on these tools, and to do so, make sure that you have this kits during the next webinar which we'll be organizing in the coming months. So let us connect the potentiometer. We have 3 wires coming out of the potentiometer, and as I already explained, if you have any queries regarding the potentiometer connection, let me know through the comment section. I'm just repeating it again and again so that all your doubts are cleared before you leave this live webinar session. So I'm going to connect the cornermost terminal to any 5-volt supply on Arduino, the other terminal to the ground terminal, and I'll be left with just one terminal, which is the variable part of the potentiometer. That's the middle terminal. Let me show you. That's the middle terminal over here. So this white wire is something which I am going to connect at analog pin this time. So these are the analog pins: A0, A1, A2, A3, A4, and A5, so on. So I'm going to connect it to A0. Okay, I'm connecting it to analog pin and not the digital ones. So that's the basic difference when we are using an analog device. So a voltmeter is an analog device and it's not a digital device. So it gives a voltage value and not just the state. So the output value of the potentiometer would vary from 0 to 5, say, because we have given a maximum voltage of 5 volts. So it would vary from 0 to 5. 0, 1, 2, 3, 4. Again, that would be 0 0.1, 0.2. So that's something variable, and that's why that's an analog input, and that's the reason which we for which we are going to use the analog pins of Arduino. Hope you guys do not mix up the analog and the digital concept. So we have connected it to pin number A0 of the Arduino. Now let us program the potentiometer. You just need to read the values from potentiometer, and to do so, I'm going to clear the workspace. I'm going to Clear the command window. I'll set up the connection of Arduino. If you still have problem on setting up the connection of Arduino, you can just go back to the video at the starting of this video and watch the webinar again, or you can just comment down in the section below so that we can understand, we can explain it. This being a live coding seminar or live coding webinar, we are asking you to ask as many questions as you can. So A equals to Arduino, I'll be using the for loop to check if the value is assigned to variable X. And now we'll be using another function which is read voltage. Now this is the function which we use for analog pins to read the voltages. Read voltage, A comma. Now that's the Arduino which we have connected, and we have connected it to pin number A0. So we have connected this to pin number A0, and let us end the. Let me save this code, okay, and run the code. Oops, we can see the Arduino is not connected. I had disconnected it in the previous section and I forgot to connect it. So these things happen. So we have to take care of everything. I've connected the Arduino now, and to check the connection again, I'll be using A equals to Arduino command. Yeah, you can read it. So I'll be running the code. So you can see the potentiometer is giving the values as 2.38. Now I'm just changing the value. If you guys can see it, I'm changing the value to 2.5, and I'm just changing it towards the 5 volts. So I'm increasing the value slowly and steadily. And that's the maximum position, which is at 5 volts. Now I'm taking it to the another direction, which is I'm decreasing the potentiometer value. Don't worry if you guys cannot see in the small screen what I'm doing with the potentiometer. I'll be explaining it in a few minutes. But before that, I want you to see these values. Like it's like 1.7791. Then I'm decreasing it furthermore. And that goes to 0. So this is how you actually read the voltage from any of the analog devices. So guys, if you have any queries till now, let me know through the comment section below. You can use our live page. You can use anywhere to communicate with me, any of our website online chat. Just let me know if you have any queries. So I believe that you guys do not have any queries, and let's move ahead. So before moving ahead, I'll have to stop the code. It will give me some errors because I stopped it in between. Now let me explain you what I was exactly doing on the potentiometer. So there's a knob over here on the potentiometer which you can change in either clockwise or anti-clockwise directions to change the resistance value. So basically what happens is the resistance value between the end terminals are changed. So let us do a very funny thing with the potentiometer. Let us program it in such a way that the brightness of the LED is being controlled with the potentiometer. So how does that sound? Yeah, that's interesting. So let's do it. And to do that, we'll have to change a few things in the circuit. So let me unplug it. Oops. Okay, so I've unplugged it and I'm not changing anything to the potentiometer, but I'm just adding one LED in the similar fashion, like the longer leg is the positive terminal, shorter is the negative terminal. I'm just adding it over here in parallel. Okay, again, I'm repeating it, I'm adding it in parallel. Now what I'm going to do is I'm going to connect the positive terminal of the LED to pin number 9 and the negative terminal to pin number to the ground terminal. So I'm connecting the negative terminal of the LED to ground terminal over here. That's it. We are done with the connection part. Now let us make few more changes in the code. Again, I'll be using the while loop. So I'm just writing the time variable. I'm setting the time variable. I'm writing the while loop. So while time is greater than 0, voltage equals to read voltage. That would read the voltage from the analog pin A0. Now to the LED to to glow it or to make it more dim and it should be visible because this is a 3.3 volt LED. We'll be setting the voltage value or we'll be dividing the voltage value by a factor of 16 so that if the maximum value is 5, the minimum value would be 5 by 16. Like the value which would reach, the voltage which would reach to the LED would be 5 by 16, which is 0.3 volts. And that's the maximum value of the LED or maximum voltage of the LED. And see the spelling mistake over here, so I'm just changing it to voltage. Now this is another command which we use to write the digital output to the Arduino. So we have already seen the um, right digital pin in the Blink program. So now we are going to write PWM voltage, Arduino at which A is connected, D9. So we have connected the LED at 9 and voltage, getting a voltage. So we have one more query on our website chat, which is by Ratnkar, and it says how voltage is varied. Okay, so the voltage is varied for using this potentiometer. As I explained you in the earlier stages also, the potentiometer basically has 3 terminals. Okay, let me quickly explain you using some illustration so that you guys can understand. So say this is a potentiometer. It has 3 terminals, terminal 1, 2, and 3. So basically there's a resistance coil inside this potentiometer. So if you apply a 5 volt over here, which we are doing it using the Arduino. So I'm just applying 5 volts to terminal 1, and at terminal 3 I'm applying the ground. So basically there's a knob over here, and when you change this knob in the clockwise or anti-clockwise clockwise direction, it will change the resistance of the potentiometer. So this is basically a resistance or a variable resistance, you can say. So depending upon the resistance, depending upon the Ohm's law, the corresponding output is acquired at pin number 2, which is the value which we can see in the command window. So this is not the value, but when we run the code, the value which comes in this place is the value which is read at pin number 2. So I hope that answers your query too. If you still have any questions, you can just let us know. I'm just moving ahead with the code. So I was explaining about write PWM voltage and like the difference between write PWM voltage and write digital voltage. So that's the basic difference which we'll be doing, and we need to decrement time to change the state. I'm just adding a delay of 0.1 seconds so that you can see the change in the state. So that's it. We are done with the code. Let me save the code and let me run it for you. So when we run the code, okay, again, we are making the same mistake. We haven't connected the Arduino board. So I know that safety is important, but you need to remember that you need to plug in the board every time you need to upload the code. So I've plugged in again and I'm clicking on the run button over here. Okay, so the position of the potentiometer might be at 0. So let me turn it in the clockwise direction and you can see the LED is glowing slowly and steadily. Let me take it furthermore and you can see the LED is fully glowing now. To see it in a better fashion, let me stop my screen and now I guess you can see LED glowing. Let me turn the potentiometer on the other side so that I can control the brightness of the LED. It's dimming. I'm just dimming the LED more. I'm doing it furthermore and more. So that's almost at 0. Okay, there's, these connections are loose, but you need to take care that these connections, don't interact with each other. So I'm just, I'll just run the code again. Okay, the issue was over here. I'll share my screen and you can see the code is already terminated. Let's do it for 500. And let me show you again. So the value of potentiometer is at 0. I'm turning it on slowly and steadily and you can see the brightness is increasing. So this is how fan regulator or any sort of brightness regulator works. So that's basically a resistance meter, which is similar to the fan application, which you can which you might have used in your homes. Nowadays, automation is into the market, but we still use these potentiometers to control the speed of the fan. So that was about controlling the LED using the potentiometer. I've already covered how to control servo motor, and in the similar fashion, you can control the servo motor as well. Like you can control the servo motor using the potentiometer itself. You just need to change these lines for the servo motors. Now, let me show you how to do this using Simulink, how to control the Blink program using Simulink, and you can experiment with the other things as well while you do that. So before we go to the Simulink part, if you have any queries regarding any of the codes or any of the function which we have used, any of the circuitry which we have used, so let me know through the comment section. You can start the online chat on our website. If you do not have the kit, you can still buy it because it's not limited to this webinar. We'll be conducting more such webinars in the coming months, and you can have those kits handy well before in time so that you do not miss the opportunity the next time. So before moving to Simulink, let me know if you guys have any queries. And if you do not have any queries, we'll just move on to the further section. So meanwhile, you're thinking on some queries, let me tell you what all things we have already covered. We have covered how to control the brightness using the potentiometer. We have seen the blink program using LED. We have installed the hardware packages for MATLAB. And before going to Simulink, let me also tell you, you have to install the hardware support packages for Simulink as well in the similar fashion, and you need to have a MathWorks account in order to install this. And the account is absolutely like it's free of cost, so you will not pay anything for using these tools. So you can just install it on your devices as well. Then we have covered how to read the data. We have seen how the servo motor works. If you have any queries in any of these things, let us know. So we'll be organizing such Arduino events in the coming month as well. So I would like to thank Airavat Foundation again. And the mission is like we do the impossible. And if you guys really want to work as a volunteer, you can just go to their website and register as a volunteer. And they are also working on such similar projects. You can learn it as well as you can um, help the human society, or you can support the human progress through innovation. So that's their tagline. We at MATLAB help assist students and professionals to learn MATLAB. So if you want to get trained on MATLAB as well as Simulink, you can visit our training page, which is on our website, and you can opt for either instructor-led online or offline training. So if you want to learn it at your home itself, so you can go for the online trainings. And if you want to learn it at our facilities, you can go for the offline trainings as well. Moreover, if you are a student and want us to organize such trainings in your campus, so do share your details via same page. Like you can just go to the training page, or you can just start an online chat requesting and support at your campus, so that we can get in touch with you and your college as well. You can find all the links in the description below on this page. You can navigate to our websites as well. So without any further delays, let us start Simulink. To start Simulink, you need to type Simulink in the command window, and I'll be opening a blank model. So in this part, believe me, you are going to learn how to code Arduino without even writing one line of code. But before that, let us change you know, the connections back to the Arduino, back to the Blink LED one. So I'm just removing the potentiometer as of now. I'm removing these extra connections. Okay. I'll be putting the LED at pin number 9, and I've connected its ground to pin number 13. So if you have a resistor of 330 ohms or 330K, make sure that you always put it in series to the LED, so that the LED does not blow off. So I haven't connected it in any of my tutorials, but you can still connect it and be sure that your LED does not blow off. So let's start with the Simulink portion. It's very easy. That would take another 1 or 2 minutes to design the entire code. So I'll be opening this Simulink library from this portion over here. So I'll just click on the Simulink library. And in this portion, if you have already installed the support package for Arduino hardware, you'll find the common blocks which are used. So in the common blocks, you'll find the digital out pin over here. So I'm just taking it over here. It's a drag drop thing. I'm just dropping it over here, which is already set to pin number 9, and I've already connected the LED to pin number 9. So if once you're done with that, I'll click on the library settings again. Now we need a pulse generator, and for that in the Simulink, like the commonly used blocks or in the sources part, you can see a pulse generator over here. If you cannot find any of these blocks, you can just use the search bar over here and type whatever the block is. So I'm just typing the pulse generator block, and the Simulink will search it for you. So you can see the pulse generator is here. Now I'm just taking the pulse generator out here, and I'm just connecting this to Arduino. Now to configure the pulse generator, you need to change the pulse type as sample based and not the time based. Use simulation time, and you can change the sample from zero point 0.1 to any value. Like this is the basic pause value which we used in the previous sections, like to change the delay of the LED. So that's the sample value over here. You can just click on apply. Okay. And we have successfully created the Blink program, you can say, and we are ready to upload it on our Arduino. But before that, we need to do very important settings every time we run the code on the any of the hardware. So it should be set to infinite, and as we are going to go with the external hard drive, that's set to external. You have to go to the tools, run on target, prepare to run, and you have to select the hardware board. So this is an Arduino Uno board. So I'm going to select the Arduino Uno board from here. It will initialize the board parameters. Now clicking on this target hardware resources, you need to check once if the host board connection is set automatically or not. And if it's not, like once you run the code and if it's giving some kind of error, like the COM port is not detected, Arduino is not detected, you can just come back over here, set this thing manually to COM port 4. I know it's connected at COM port 4, and if you want to check it, you can again type our command, which is a equals to Arduino, simply Arduino in the command window. Now it says the Arduino connection already exists, so I need to clear all. I need to delete all the workspaces, all the variables in the workspaces, and check for a new connection with Arduino. So it says it's connected at COM port 4. So that's how you check it. Coming back to the Simulink portion, we need to also clear the workspace so that the Simulink does not conflict. And I'll click on apply now. Once we are done with it, going back to our Simulink model, we can just click on this run button over here, and that should build the code on the Arduino itself. So it's still in the building stage. You can see it on the Arduino if that's successfully installed or not. It's still taking some time because it's the first time we are pushing it on the Arduino board. So I'm just waiting for the Arduino to glow. So you can see it's done. I've pushed the code on Arduino, and because the sample time was 1, it's running, it's glowing for 1 second, that the LED is on for 1 second, and it turns off for 1 second. So that's it, guys. If you have any queries so far, let us know, because we are going to end this webinar in a couple of minutes. So if you have any queries, let me know through the comment section. If if you want me to explain anything again, let me know to the comment section again, so that we can close this webinar. And we'll be having such webinars on Arduino regularly. So stay in touch. If you want to get updated, do register on our website for such events. We'll be sending you updates on such events. And if you want to get trained in MATLAB, you can visit the training page on our website, and just opt for an instructor-led online course or instructor-led offline course. And if you want us to give such trainings at your campus, we would be happy to see you at your campus. So if you guys have any queries, let us know. I'm just waiting to just wrap up the meeting, wrap up the live coding session. So hope you guys, enjoyed the live coding contest. And if you have any feedback for the contest, you can write it to us at team@matlabhelper.com, or, you can just comment in the section below. You can, uh, start an online chat so that we would know feedback for this session as well. So that's it, guys. If you want to buy the Arduino kit, the links are in the description. If you need any help, the links are mentioned in the description. So bye-bye, guys. Have a great evening and hope to see you soon in the next Arduino event. Bye.